All right, today we're going to find the centroid. So the first thing is I want you to put your name on your paper, first and last name. And then this is what, second hour? And then today's date is the 29th. All right. And we're going to, the first thing we're going to talk about are medians and centroids. I had to think which one we were doing today, which is funny because I just did it last hour. All right, so what's a median? Median in your language would be a segment from the midpoint of a side to the opposing, or we'll say opposite, vertex. That's a very informal definition, but I think it'll help you guys to remember what you're doing. So the first thing we want to do is we want to draw an acute triangle. So I'm going to draw, remember you don't want it to be too big. You want it to be kind of in the middle of the paper. You don't want a 90-degree angle. So this is like a 90-degree angle. I don't want that. I want it acute. So I'm going to come in just a little bit. And then I'm going to connect those lines like this. Okay. And I'll label this A, B, and C. Okay. So now to find the midpoint of a line segment, I could do it with the compass, and we actually did it yesterday when we did the perpendicular bisector. But the midpoint is pretty easy. So what I want you guys to do is take your compass. We're going to find the midpoint of AB. So take your compass and put it on, take the pointer part, dig it into A. And then to find the distance, when you go to find midpoints, you want to go about 3/4 of the way of the line segment. So I'm going to find the midpoint of AB, which is going to be about right here. Okay? And to find the distance on the compass, because I'm going to draw these arcs, I'm going to move it to about 3/4 of the way. Now from here, I'm going to lightly sketch an arc. Okay? Now you might not be able to see it, but I want it to be light, because if I draw it too dark, then it gets crazy and confusing, because you have all kinds of arcs and stuff. Arcs and lines and stuff like that. Now, without changing this distance, I'm going to take my compass and I'm going to put it at the pointer B. I'm going to put the pointer at the point B, and I'm going to make another arc. And I'm going to make a large sweeping arc, but I'm going to make it lightly. Okay? Now, if I take my ruler and I draw a line through this, but I'm not going to draw a line. But if I were to draw a line, that would be what we call a perpendicular bisector. Perpendicular meaning it crosses the line segment AB at a 90-degree angle, but the bisector part is what we're interested in. It divides it in the middle. Yes? Do you have a question, or are you stretching? Were you stretching? Okay. All right. So I'm only interested in that part there. So if I line my ruler up at the two intersections of the arcs, I'm only interested where it crosses the line segment AB. So right here, where that is, we're going to call that R. Okay? So that point is the midpoint of AB. So let's write that down. We're going to say R is the midpoint of AB. Now, midpoint, by definition, means that AR is congruent to BR, right? In other words, this length from A to R is congruent to BR. So I've divided the line segment AB into two equal parts by drawing the midpoint R. Now, the centroid is where the medians converge. It's the point of concurrency of the medians, and we'll write that down in a second. But what's a median? It's a segment from the midpoint of a side to the opposite vertex. So look at R and tell me which vertex is the opposite of R. C. C. So from R, opposite of R is C. So I'm going to take my ruler and I'm going to draw a line from C to R. Okay? And then, just so you guys kind of know what's going on, let's write it down. CR is a median of triangle ABC. So now we're going to do two more medians, and where those three converge, that is the centroid. And that has a very unique property, and we'll get to that in a second. Now, if I haven't adjusted my compass, and if you did, it doesn't matter, but again, I want to take and make sure that the distance on my compass is about 3/4 of the way to C, because we're going to do the midpoint of BC. Well, I kind of cheated, and I drew this all the way through. That's okay. As long as I don't change this distance. Now, if you have to change this distance inside here, that's okay too. It just has to be the same for B and C. So for me, my B is here. And then I'm going to go to C and do the exact same thing. I'm going to draw a line segment through C. Whoops. My pointer came out of the little thing that I did. So I'm going to come through here, and I'm going to draw an arc through C. Okay? Real light arc. And then if I set my ruler up here, if I were to draw a line, that would be a perpendicular bisector. I don't want a line, though. I just want this little point of intersection right here. Okay? So I'm going to find the intersections of my arcs, and then I'm going to set my ruler up, and I'm going to put this little mark right here. That is S. What is S? S is the midpoint. I misspelled the word point. I don't know why I keep doing that. I did that first hour. Midpoint. I think it's because of the mid part. The midpoint of which line segment? BC. Very good. So what do I know about that? If that's the midpoint of BC, then what can I write next?
My point's going to be way up here. Is that okay?
What's that?
My point's going to be way up here. Is that okay? My triangle is a little different than yours.
The midpoint should fall right between B and C.
Okay, did some wrong.
Okay. Let me see your picture. No, it's not. You did it right. Okay, so, student,
Maybe obviously not.
a student gave me this. He said, I don't think mine's going to be in the middle of BC. What he did is he did the same thing I did. He drew full circles, but he did nothing wrong. He said, my point's going to be way off somewhere else. But this is the intersection, this is the intersection. If I put the ruler right here, guess what? This is the midpoint of this. And it's smack dab in the middle of BC. So you did it right. What were you doing? Were you trying to draw these lines or something? Okay, that's okay, but guess what that is? That's the midpoint of AC. Okay, you're a little bit ahead of me. All right, so what is the, oh, I forgot to say this. So this then, by definition of a midpoint, it divides the line segment BC into two congruent parts. In other words, BS is congruent to CS. I don't know if we need to call it congruent or equal. It really depends on if we're talking about the value or the construction. Sometimes kids get confused. All right, so then what side or vertex is opposite of the point S? A. So I'm going to draw a line between A and S. Okay? So then I can say AS is a median of triangle ABC. Okay? Now, if I've done all my work properly, that third median should cross right there, and that should be what we call the centroid. All right? So let's repeat the process. Now, if you made the big arcs, and I kind of cheated, I did it this way, but it doesn't matter. I have an arc here, and if I go to A, I'm going to construct my arcs here. Right? And so I have an intersecting point here and an intersecting point here. So if I line those up, I'm only interested where it crosses right here. Okay? That is the midpoint, T. What vertex is opposite of T? B. It's easy to kind of zone out, I guess. And then I draw my line through there. All right, so then we can say a couple of things. We could say that T is the midpoint of AC. Now, what does that tell me about those two? In other words, what does that tell me about AT and CT? They're equal. So I could say that AT is equal to CT. So I'm going to put 1, 2, 3 tick marks there and 1, 2, 3 tick marks there. This point right here, we're going to call that the point P. And P is the centroid. Now this center has a property. Oh, I probably should list this too. BT is a median of triangle ABC. And then to clearly define what it is, P is the centroid comma, the point of concurrency of the medians. I run into this a lot. They'll say, Mr. Adams, why do you use the fancy words? They make it difficult. No, math is difficult. I have to use the fancy words because that's what they put on the SAT. What do you guys think point of concurrency means? Where they all come together, where they meet. Where they meet. So let's put that down. Where they cross. Okay? Now the property that's interesting about this, and I want you to do this, and I'm not gonna tell you the property. We're gonna do this, and then you can come up with the property. Are you ready? Take your compass, put the pointer on point T, then put the pencil, actually put the pointer on point P. Put the pointer on point P, dig it in a little bit on the paper. And then set your pencil. See what I'm going to do? I'm going to set my pencil so the pencil is right on the point T. Okay? See how I've measured that with my compass? Make sure that you've done the same. The easiest way to do it is put the pointer on there and then just kind of move it to the side and get that pencil right there on that point. Is everybody there? Now watch what I do. I'm going to rotate this around and I'm just going to make a little intersection right here. See how I did that? I'm just going to make a little teeny tiny mark right there. All right? Does everybody have their little teeny tiny mark? Now watch this. If I take my pointer and put it on that little teeny tiny mark right there where it intersects, I gotta dig it in a little bit. If I put it right there, it comes to B. Okay? So it's kind of hard to see, but if you do it right, whoops, my paper slipped. If you do it right, it should come to B. So let me, whoops, it keeps slipping off my paper. But see how that comes to B? So if I hold this right here, see how that measures to B? So now watch this. This measurement is the same as this measurement is the same as this measurement. I wonder if that happens with the other ones, with the other sections. Turn your paper sideways. I'm going to take my pointer, put it at the centroid. I'm going to measure the pencil from point P to S. Oops, I put a hole in the paper. Okay. Then I'm going to rotate it around and I'm just going to make a little mark right here like this. Okay. Then I'm just going to measure it. See that? See that? See that? What does that divide the median into? 3 equal parts, right? What do you think will happen on that last median? Same thing, it'll divide it into 3 equal parts. Let's try it to see. Now I'm going to rotate my paper here. I'm going to take my pointer, I'm going to put it right here. I've dug a hole through my paper on point P. I'm going to set my pencil up here on R. I'm going to rotate around, and I'm going to draw a little mark. And if I measure from here to here, and here to here, and here to here, it divides it into 3 equal parts. Now, if I were to write a rule, I would compare it to the median. So I'm going to say PT is equal to, from here to here, is equal to something BT. So what is this length compared to the full median? 1/3, right?
Yep.
Then I could say that BP is equal to 2/3 BT, right? And I'll just, you write that down and then just look at it and let it soak in. Now, if I were to say to you, PT equals 6, and I said to you, what's BP? And then lastly, what's BT? In other words, the distance from here to here is 6. If this is 6, what's the distance from here to here? If the distance from here to here is 6, the number 6, what's the distance from B to P? Well, 6 is 1/3 the distance of the median, right? Well, let's just do the algebra way. I know that PT equals 1/3 BT. And I'm told that PT is equal to 6. So I could say 6 equals 1/3 BT. How do I get rid of this 1/3? What's the opposite of dividing by 3? Multiplying. So I'm going to divide this by, or multiply by 3, and whatever I do on one side, I do to the other. What's 3 times 1/3? 1/3 of 3 is 3 divided by 3 is 1. What's 1 times BT? BT. What's 3 times 6? 18. Good. Now, if this is 2/3, so we know that BT is 18. And we know that PT is 6. I know that PT plus BP equals BT, correct? Look at your triangle. I know that this is 6. I know that this is 18. What does the length of BP have to be? How could I find that? Subtract what? Subtract 6 from both sides. So if I subtract 6 from here and I subtract 6 from here, I get that BP is 18 minus 6, which is equal to 12. See how I did that? That's what your problems are going to be like. I'm going to give you a worksheet with a bunch of these problems on it tomorrow. But I wanted you to see that when you construct a centroid, it divides that median into thirds, where the longer part is 2/3 the length of the median, and the shorter part is 1/3. By the way, what's 6 times 3? 18. If that's 1/3, what's 2/3 of 18? 12. Okay? Can we flip our papers over? We got one more thing to do. This will probably take us right up until the bell rings. I'm sorry, but that's what we got to do. You're going to write altitudes and orthocenters. This time when we draw a triangle, I'm going to draw like a an obtuse triangle, but I'm going to extend the line beyond the triangle, and you'll see why in a second. So I'm just extending these lines beyond the triangle itself, and you'll see why in a second, because sometimes finding the orthocenter is not the easiest thing to do. So I want you to do the same. Just kind of draw something like that. So you can see where the triangle is, but I've extended the lines. And let's call this point here, this is D. Let's call this point E. Let's call this point F. And then I'm going to darken the actual triangle so that you guys can clearly see what our triangle is. Okay, so what I need to do is I need to find that the orthocenter is where the altitudes converge, the point of concurrency of the altitude. But the altitude needs to form a 90-degree angle with the triangle, with the base. So I'm going to find the altitude of this triangle. So what I need to do is I need to draw a line that forms a 90-degree angle with D. Okay, or actually with the base EF. So what we're going to do is we are going to take our compass, and I'm going to take and put the pointer on point D like this, and I'm going to go slightly past this line. Now notice that in order to go slightly past this line, I'm going to go outside of the triangle. So if I take my pencil and I draw an arc, it will look like that. And it goes slightly outside of the triangle. And I'm going to look at the arc, and I'm going to find this intersection, and I'm going to find this intersection. Now sometimes when we draw the altitude, it's inside, and sometimes we have to extend the lines to draw the altitude outside. So now, to draw the altitude, it has to form a 90-degree angle with the base or the imaginary line of the base. So I could hold this like this and say, pretend that this is the ground and I built a figure that's sitting on the ground. Where would I need to put a piece of construction that would support the weight of the triangle or something like that, right? So I would want it to form like a 90-degree angle, sort of like this. But I can't just freehand it. I can't just sketch it. I got to find the 90-degree angle. So to draw a 90-degree angle that goes through the point D, I'm going to take my pencil. I have these two intersections. I'm going to take my compass, and I'm going to go about 3/4 of the way that length. Okay? So I'm going to call this point here, we'll just call it P. And this point here we'll just call Q. And so I'm going to go about 3/4 of the way from P to Q like this. See how I'm doing that? And what I'm going to do is I'm going to make another arc that sweeps around, and then I'm going to go to P, and I'm going to put the compass there, and I'm going to make another arc that swings around this way. And so what I have is I have two arcs that should go right through the middle of PQ, but I've constructed that in a way that it will also go right through the point D. So I'm just going to draw a line like this, okay? And that is the altitude of D. So the orthocenter most of the time is inside the triangle, but I wanted to draw one outside the triangle so that when you stumble across it, you would know what to do. Now, if I were to find the altitude height of DE, so I'm going to rotate my paper this way, where DE is the base now, I'm going to find the altitude height from this point F. So what I'm going to do is I'm going to take my compass, I'm going to put the pointer right on F, and I'm going to move the pencil till it's just slightly outside of the side DE. So see how I have that on the screen? See that? Then I'm going to make an arc like this. Now this altitude will be inside the triangle, sort of. So that arc intersects this side and it intersects this side. Now, for me to draw a line that intersects DE at a 90-degree angle, I'm going to have to draw a perpendicular bisector, which is the midpoint of this. So I'm going to call this PQ RS. And so what I'm going to do is I'm going to take my pointer and I'm going to put it on S, and I'm going to measure about roughly 3/4 of the way to R. So my pointer is on S, and I'm going about 3/4 of the way to R. Okay? From there, I'm going to make another arc. And then I'm going to do the same thing on R. Not changing the distance of the compass. And now I have two more arcs that intersect. They intersect here, and they intersect here. However, when I put the ruler there, I noticed that it also passes through the point F. That's no accident, so I draw that line. Now notice that these two altitudes, so this is an altitude, this is an altitude of the triangle, but they don't converge inside the triangle, they converge outside of the triangle. Okay? So I have one more altitude to find. And that's going to be for the point E. Now for the point E, I'm going to have to do the same thing. I'm going to have to find the altitude, I'm going to have to take and put the pointer on E, like this. I'm going to have to dig that in at E. Okay, and then I've got to extend this, my compass, so it goes past this line. And I'll extend it out a little bit more than normal. So from there, I need to make an arc through this line. And so I have an intersection here, and I have an intersection here. I'll call this point T, and I'll call this point U. So now I have to draw, and we're almost done, guys. Hang in there. We've got 7 minutes left of class, and we'll finish in plenty of time. Now, to make a perpendicular bisector that goes through the point TU, again, I got to take my compass and make sure I'm about 2/3, or not 2/3, 3/4 of the way to U. So I'm measuring my pencil. That's okay. So I'm going to put my pointer here. I'm going to make one more arc. And then from U, I'm going to make another arc without changing the distance of the compass. Now this intersection is going to be about right here. This intersection is going to be about right here. So if I line my ruler up, notice that those two intersections go through the point E. And if I draw the line, I get all three of these lines converge right here. This is the ortho, R. the orthocenter of triangle DEF. Okay? And the orthocenter can be completely outside of the triangle. I'm going to highlight mine so you can see it. Normally in your textbooks they use different colors. So your triangle, well, let me highlight the altitude. So this is one altitude. This is an altitude. And this is an altitude of the triangle. Okay? So those yellow lines, which you really can't see, I guess, maybe if I zoom in a little bit. Those yellow lines, let me make it thicker so it's more obvious. Those are the altitudes of the triangle. What's the actual triangle? Well, your triangle looks like this. Now the orthocenter doesn't have like a very unique property with regards to like what you guys would use it for, like an algebraic thing. We'll talk more about it tomorrow, but today I just wanted to show you how to construct an orthocenter, and I purposefully used an obtuse triangle. So for obtuse triangles, most of these centers are outside of the triangle, and that's okay. Do you guys have any questions? And this, of course, this of course is your orthocenter. Okay. Yep. So what I need is I need one volunteer to collect those.